So, what is our world actually going to look like in the year 2100? It's a question that can feel pretty huge, maybe even a little scary, but it's also a question that scientists are tackling head-on with some serious data and incredibly powerful computer models. Today, we're going to walk through that exact forecast piece by piece. Let's get right into it.
Right, that's the big question, isn't it? How can we possibly know? Well, this isn't about gazing into a crystal ball or just pure guesswork. It's actually the result of a really rigorous scientific process, using everything we know about our planet today to map out what's possible for tomorrow.
So, what are the tools of the trade here? Well, scientists combine a few key things. First, they start with decades and decades of real-world observations, actual data on our climate. Then, they feed all of that into these super powerful computer programs called global climate models. You can think of these like virtual Earths, where they can simulate the future. They also factor in major assessment reports and, crucially, different scenarios for our future greenhouse gas emissions. It's that whole combination that paints such a detailed picture.
Okay, before we dive any deeper, let's just make sure we're all on the same page. When we're talking about climate change, what we mean are these big, long-term shifts in our planet's temperature, rainfall, and weather patterns. And the main driver behind all of it? That buildup of greenhouse gases in our atmosphere.
All right, now for the main event. Let's look at what those changes are actually projected to be. We're going to start with the most direct physical alterations to our planet. First up, the big one, temperature. Scientists project that the global average temperature is set to rise somewhere between 1.5 and 4.5 degrees Celsius by 2100. Now, I know what you might be thinking. That doesn't sound like a lot for a single day, right? But think of it like your own body temperature. A fever of just 1 or 2 degrees can make you feel seriously sick. For the entire planet, a shift this big is a massive and, frankly, dangerous change to its whole system.
And here's a really crucial detail. That heat is not going to be spread out evenly. All the models point to the exact same thing. Land areas are going to warm up much, much faster than the oceans will. And that has huge implications for, well, pretty much everything, from what we can grow to where we can safely live.
Next up, what about rain and snow? The forecast here is kind of paradoxical. We're actually projected to see fewer rainy days overall, but, and this is a big but, when it does rain, it's expected to be a lot heavier. So that means we're looking at a serious increase in extreme downpours and less predictable weather, like the monsoons that literally billions of people depend on for their water and food.
All that warming, of course, brings us to our coastlines. The projection for sea level rise by 2100 is between 0.3 and a full meter. Just take a second to picture that. A meter of sea level rise is a direct threat to coastal communities, major cities, and entire ecosystems all around the globe.
So you might be asking, where is all this extra water coming from? Well, it's coming from two main places. First is just simple physics. When water gets warmer, it expands. It's called thermal expansion. And when you're talking about the sheer volume of our oceans, that expansion really adds up. Second, and this is the one we all think of, ice on land is melting. We're talking everything from mountain glaciers to the massive ice sheets at the poles, and all that water is flowing straight into the sea. Okay, let's stick with the oceans for a minute because the pressure they're under is really a twofold threat, and it's super important to understand them as two separate issues.
So on one hand, you have ocean warming. As the oceans absorb all this extra heat from the atmosphere, we see devastating effects, like mass coral bleaching, and we see fish populations literally moving to find cooler waters. Then, on the other hand, you have ocean acidification. As the ocean soaks up more carbon dioxide, its actual chemistry changes. Its pH level drops, making it more acidic. This is terrible news for creatures like oysters and clams that need to build shells, and it really messes with the entire marine food web. So yeah, two distinct problems, but they share one common cause.
So we've talked about these huge physical changes happening to the planet itself. But how does that connect to the real-world crises we see on the news? Well, think of it like a chain reaction, or a domino effect. One thing directly triggers the next.
The chain reaction is actually pretty simple and logical when you lay it out. It all starts with the root cause, that increase in greenhouse gases. The first domino to fall is global warming, as those gases trap more heat. That warming, in turn, topples the next domino by altering climate patterns. Those are the shifts in temperature and rain we just talked about. And the final and most direct impact on us? Those changes supercharge our weather, leading to more frequent and more intense climate disasters.
And here's what that looks like on the ground. The projections basically show a world of extremes. On one side, more intense rainfall is going to lead to more devastating floods. At the same time, though, other areas will see longer dry spells, triggering severe droughts. And while we might see fewer cyclones overall, the ones that do form are expected to be far, far stronger. And draped over all of this are more frequent and longer-lasting heat waves, which will strain everything from public health to our ecosystems.
Now, I know these global trends can feel a bit abstract, so let's bring this down to earth and zoom in on one specific regional forecast. For a country like India, the projections point to a much more unpredictable monsoon season, a rise in both floods and droughts happening in different areas, and stronger cyclones forming in the Bay of Bengal. Each one of those directly threatens the lives and livelihoods of millions and millions of people.
Okay, so look, these projections are definitely stark, but they are not destiny.
The science doesn't just point to the problems, it also points towards a path forward. And that path is all about building resilience.
So what's the key takeaway from all this science? What's the game plan? Well, it really boils down to a three-part strategy. First, we need climate-resilient management. That means building smarter infrastructure that can actually withstand these new extremes. Second, we have to get way better at disaster preparedness before things happen. And third, we have to manage our critical resources, like water and food, way more sustainably. Basically, we need to get ahead of the problem.
So there you have it. The science has given us the forecast. The models have shown us what's on the horizon. The only real question left is the one you see right here. Now that we have a clear idea of what's coming, are we ready for it? Thanks for joining me for this explainer.